As a self-respecting chemistry student, you would surely recognize the term Avogadro's constant. You might even be able to define it as the number of particles in 1 mole of a substance, or even recite the constant as 6.02 times 10 to the power of 23. But do you know how the number came about? It all started in 1811. Italian scientist Amedeo Avogadro proposed that equal volumes of gases at the same temperature and pressure contain the same number of molecules. That was a key idea, but he never calculated the actual number. The concept of a mole as a unit came later, around the late 19th century, as chemists began to relate masses of substances to numbers of atoms or molecules. In the early 1900s, Albert Einstein mathematically described how small particles in a fluid move erratically due to collisions with molecules. He derived an equation relating the diffusion coefficient to Avogadro's number. Jean Perrin experimentally verified Einstein's theoretical explanation of Brownian motion by using a microscope to track the movement of tiny particles suspended in liquid. From observed data, he applied Einstein's formula and estimated the number of molecules in a mole to be approximately 6.06 times 10 to the power of 23. In recognition of Avogadro's earlier theoretical insight, Perrin named the number Avogadro's number. Over the years, the number was also determined and refined to 6.022 times 10 to the power of 23 through other experiments such as Faraday's electrolysis, Millikan's oil drop experiment, and Bragg's X-ray crystallography. In 2019, Avogadro's number was fixed as a constant. The value was derived in the International Avogadro Project. Scientists used a 1 kilogram single crystal of silicon, 28, manufactured as a perfect sphere. Silicon's atomic spacing is known extremely precisely from X-ray crystallography. By measuring the mass, radius, and lattice spacing, they calculated the number of atoms in the sphere, and thus in a mole, to be exactly 6.022140076 times 10 to the power of 23 particles. This value was fixed as Avogadro's constant in 2019 to redefine the mole and indirectly support the redefinition of the kilogram based on fundamental constants.